All right, let's kick things off. We're doing a deep dive today, looking at a pretty detailed research report all about Docker.
Right. Covering not just the nuts and bolts, but also, why it became such a big deal.
Exactly. So our goal here is to unpack that research, get you up to speed quickly on what Docker is, and crucially, why it really changed the game in software.
And the sources really start by highlighting this fundamental problem Docker aimed to solve. A problem many listening have probably will run into.
You're talking about the classic "it works on my machine" issue, aren't you? Where your code runs fine locally, but then boom, breaks somewhere else.
Precisely. Test servers, staging, production, a teammate setup, anywhere different.
Yeah.
The report points out these subtle environment differences. OS patches, library versions, you name it, were just constant sources of friction.
A real headache. So, okay, how does Docker step in? What's the core mechanism according to the research?
Well, the big idea, drawing from older concepts like Solaris zones or FreeBSD jails, but making it super accessible, is packaging. You package the application with its entire environment.
The whole environment, like the code, the runtime.
Everything. Code, runtime like Python or Java,
Yeah.
system tools, libraries, basically anything the app needs to run. It all gets bundled into one standard isolated unit.
Which we call a container.
That's the one.
Ah.
And the key insight the report stresses is consistency, because everything's packed inside. That container runs the same way, reliably, everywhere, on your laptop, on a server, in the cloud.
As long as Docker itself is installed there, right? It sort of abstracts away the host machine's specifics.
Exactly. And that, the report argues, is why it took off. This consistency and portability made it a de facto standard. It wasn't just a tech fix. It, enabled new workflows.
It sounds like it streamlined things massively. The report mentions impacts on development and delivery speed.
Absolutely. And CI/CD pipelines, continuous integration, continuous delivery. Having these standardized container environments, it cut down integration problems hugely, sped up release cycles. That's a major point in the sources.
And the report makes a clear distinction between these containers and traditional virtual machines, VMs.
Yeah, that's crucial. VMs virtualize the actual hardware. So each VM needs its own full operating system.
Which means they're kind of heavy, slow to start up.
Very resource intensive. Containers, though, they virtualize at the OS level. They share the host machine's OS kernel, but keep the application spaces isolated.
Ah, so much lighter weight then.
Way lighter. It's why you can pack more containers onto a server than VMs, and they start almost instantly. It's like starting a process versus booting a whole computer.
Okay, and this ties into the idea of images versus containers. I saw that mentioned.
Right. The report describes the image as the blueprint. It's that read-only package with your app and its environment, often defined in a text file, a Docker file.
So the image is the template.
And the container is a live, running instance of that image. The image acts as the single source of truth, ensuring everyone's using the exact same setup. Consistency again.
Which makes it useful all over the place, not just deployment, dev environments, testing.
For sure. Standardizing dev and test setups makes debugging way easier. And it enables things like microservices, each little service in its own container, simple to manage and scale. The report even mentions data science, ensuring reproducibility there.
So it's powerful, but the sources also caution about best practices, optimizing those Docker files, security.
Definitely. Things like using multi-stage builds to keep images small, choosing minimal base images, and critically security hygiene, like not running containers as the root user if you can avoid it.
Got it. So fundamentally, Docker delivers speed and consistency.
Speed, consistency, portability. Build, ship, run reliably.
And the report uses this interesting phrase, Docker functioning like an operating system for containers, managing the application lifecycle inside them.
Yeah, it's a useful way to think about it. It shifts your perspective, doesn't it? Instead of installing software onto an OS, you're creating this self-contained, portable unit managed by Docker.
A self-contained world for your app.
Exactly.
Yeah.
So think about that shift. Your application and its environment bundled together, portable, managed. How does that change the way you could build, share, or run, well, almost any kind of project?
Yeah.
What possibilities does that open?